if I did it this way, true? Whoops. So when I'm going to find the z-score, it's what? Parentheses, 0.68 minus 0.8. I close the parentheses. I divide the square root. A lot of you are like, I'm not doing this. Okay. 0.8 times 0.2. Then I have to divide the 75. I mean, seriously, when all that right there, I could accidentally type the wrong symbol or something, right? This is now my z-score, negative 0.259, 2.59. And then I would do my second distribution, normal CDF. Now I would put all my z's. So my low z would be this negative 1 E99. My high z would be that number. And when you okay if I just write ants, the last answer, that'd be my high z. The mean of z is always the 0. And what's the standard deviation of z every time? 1. This should give me the same answer that you two got and everyone else got. The point what? 0.004. Let's see what I get. Ta-da! 0.0046 or 0.005, right? But who, let me see, who likes to do that? Let me see no hands. I agree with you. You're like, hey, in life, let's take the shortcut. True? Awesome. Hey, we'll do another one. This time, at least there'll be something in real life. It won't just have a 0.8. Something we can relate to. This is from the textbook. This is page 419. And when this deals with credit cards, and this is what they got. Out of the way. Number 18A. So page 419, number 18A. All right, what do they got? All right, according to creditcard.com, this sounds made up too. Just by that, you agree? Creditcard.com. According to creditcard.com, 29% of adults do not own a credit card. All right. Do not own a credit card. Here. Get that out of the way. Get that out of the way. And I'm still going to ask this question about the requirements, so I might as well leave these. Is the distribution of P at approximately normal? Let's erase this. I'll get this out of the way. I'll get this out of the way. Okay. I'll get this out of the way. From our last portion. I'll leave this up in case someone here likes to use Q. What's the requirement for 8.2? What's our requirement? N times rho times 1 minus rho must be greater than or equal to 10. And N must be less than or equal to 0.05 of big N. Okay. That means the distribution is approximately normal. If that holds true. Okay. But when I only wrote the first sentence in 18, I only wrote the first sentence. The very first sentence says, according to creditcard.com, 29% of adults do not own a credit card. Now, they didn't tell you what letter this is. Do you know what letter this is?
Yeah, P.
This is that row. So I just want to make sure you're aware of that. I know, that could be the first thing that can confuse us. Here's the first sentence. They never said rho equaled this. But we're able to interpret this. We could say, all right, by the way they're writing this, they're talking about the population. 29% of, they didn't just say the adults over here in this class. They're talking about all adults. So we're going to make, that's our row. Here.
So, as far as N, can N never be a percentage?
That's right. N can never be a percentage. But rho will always be a percentage. And this is our row, everyone. So I'm going to go up to the side and go, all right, this problem, Now I know that rho equals 0.29, right? Rho is always a percentage. But n, sample size, he goes, that can never be percentage. Never. Be like 12, 50, or 100. So they haven't given us this p hat yet, have they? That'll come up in the question. All right, what else they got? They said a random sample of 500 adults was obtained. So I'm going to write that down. That's the next sentence. I want a random sample of 500 adults is obtained. Okay? Period. And here's letter I. Is the distribution of p hat approximately normal? We expect this to be yes, right? We're all expecting this to be yes. All right, but let's make sure. Let's make sure this is yes. Is that sample size big enough? So here's where I'm going to perform the checks. I'm going to do n times rho times 1 minus rho and make sure I get 10 or higher. Or just call it NPQ. And hey, when I write this down, remember, can I just write this down? I don't have to show all the numbers, but I'm just checking, everyone. Is this right here greater than equal to 10? Oh, and you could write it that way. You find that easier. N times rho times Q. Is it greater than equal to 10? That's what we're checking. Well, is it? I'll let you all check. You go, I don't know these numbers. Okay, that number right there is what?
500.
500. Good. I can write that down. I see that's a 500 right there. All right. N's 500. So is 500
It's 0.29.
times 0.29. Now, Erica, remember I go, how do we get this other number? And Brianna, here we go again. I got to get this other funny number. I'll take 1, subtract it. And you can do it separately on the calculator. What's 1 minus 0.29? Oh, good, 0.71. We just want to make sure it's 10 or higher. Even statisticians and stat teachers find this boring. You know, you're just doing a check. Just making sure we can do the problem.
It's way higher.
We want to make sure the distribution of p hat's approximately normal. I know. Is it?
It's way higher.
Check.
102.95.
We're good. Hey, isn't there one other requirement though?
Uppercase N.
I go over here on, oh yeah, there's one more thing. I gotta make sure that the sample size is lower than 5% of big N. And we're looking here, everyone. Do you see big N anywhere?
No.
So now you get to guess. You estimating stuff. What's big N? We're talking about adults.
Population.
You know, they didn't say in the nation, so I guess we could assume in the world. Aren't there billions? There's like, you know, close to 7 billion people in the world. But, you know, if we just use 1 million, is everyone okay with that?
Okay.
I'm being honest. If they don't give me big N for this, I can use 1 million here. But it's still going to check out, isn't it? So I'm just going to write that down. N is less than or equal to 0.05 big N. You bet, everyone. I don't care if you don't even type that out on your calculator. Absolutely. 500 is way, way, way smaller than 5% of 1 million. Let alone 5% of 1 billion. Just check it off. You know? You can check it though if you want there to you, but it is way smaller than 5% of 1 million or 1 trillion. It's good to go. So I get to put a what?
Yes.
You know? And what I'm trying to emphasize here is we probably couldn't do like 50 adults. You know, it might have been too small.
And should you also use Y? It's a random. Should you include that?
Yeah, I love that. I love when you write that. Where you're the true statistician, when you come over here in these checks, and you point out that it is a random sample. That goes back to chapter 1, everyone. Someone just did this, and you go, wait a minute, but how'd you get those people? How'd you get these 500 adults? Well, they all work at my company. We're like, no. You gotta do it randomly. You can have major bias, right? I have 493 men and only 7 women. Whoa. You can have some major bias in this, true? So that's what we're pointing out, so I'm gonna put that random sample. All right, here it comes. The question is, and it was actually letter E, but I'm going to call it B here. In a random sample of 500, remember they said that? In that random sample of 500 adults, and here I go, but you're gonna have to figure out the p hat. What is the probability that they said 125, but 125 or fewer do not have credit cards. Or I should say own. Do not own a credit card. And we're going to work out this math. Now, I think this time we're going to bypass step 2. You okay with that? Because Gary, we could do that on the test, right?
Yes.
Heck yeah, that's right. Hey, this picture's important though. So I'm going to make my bell, right? Step 1, we make a picture. What's in the middle?
0.29.
0.29 is right there in the middle. And when there's something wrong if I just wrote 125 over here?
You have to do it like
Yeah, oh good. People are going, you're wrong. This is not even close to 0.29. In fact, it wouldn't be on the left of that. I need a what?
Divide
The
by
p hat. So let me go off to the side. I love it. What's p hat? X over n. What's x over n? Ooh, good. I hope it's neat. Ooh, what's it come out to be? Ooh, thank you. So now we're trying to see what's the chances that 25% or less do not own a credit card. That's the question here. Hey, anybody in here do not own a credit card? There's a lot of hands. I refused to get a credit card for years. And then my dad said, good luck trying to buy a car. So I went and got a credit card. I was a cash person. I didn't have any credit report. I was like, what are you talking about? I don't need a credit card. And he's like, well, good luck trying to buy a car, eventually a house. I'm like, huh? He goes, you need a credit report. And I'm like, all right, well, now I've got a credit card.
I got 3.
Here's good. All right, look at that shader region. What's the low p hat? -1. Good job, -1e99. Comma. What's the high p hat? I'm not going to write 125.
0.25.
It's this 0.25. It's the 0.25. So 0.25. What's the mean of p hat? It was right there, which is what? 0.29. Now, everyone here's what I just typed this out. I'm going to just type this out. It's got a square root. Calculator puts a parentheses. It's rho times 1 minus rho. We figured that out to be what? 0.71. Is that right? Okay. Rho 1 minus rho. Because I don't like to write the parentheses. I want to eliminate as many parentheses I have to write as possible. That's rho, that's 1 minus rho, and then I divide the sample size of
500.
Let's see what we get. I just don't think it's going to be a high probability. I have a feeling this is going to be low. That sounds unusual for this to happen. What was it? If it was a random sample. It may happen in certain circumstances where it's not randomly selected. 0.024, do y'all get that?
Yeah.
0.024. Hey, one more thing before you leave. Sometimes people see this on a test. They do everything right, except they interpret that proportion wrong. So let's just say you're on a test, and they tell you that the rho, the population proportion is 7%. Okay? 7%. Ooh, say it again. Tia, what is this? 0.07. And guess what students may accidentally do? 0.7. This is 0.07, right everyone? Hey, great. Hey, test Tuesday, it's on chapter 7, chapter 8. Cool? Everything's normal in this distribution except for the binomial stuff. Cool? Hey, as you're walking out, if someone needs an extra sheet, I'm going to hand it to you. Tia, I think you need a sheet. Bye, Caitlin.